Imagine you have a big decision to make, like choosing between joining the basketball team or the debate club. You think about all the angles, your skills, your friends' opinions, and what you might enjoy more. You weigh your options carefully before making your choice. This feels normal, right? You're thinking about the past and present to decide your future. But what if I told you the future might also be influencing your decision, even though you're not aware of it? This might sound crazy, but it's a serious possibility that some physicists are exploring, thanks to our deepening understanding of the quantum world, the realm of atoms and particles. In this strange world, particles don't always follow the usual rules of time. They can be influenced by events that haven't happened yet, blurring the line between cause and effect. This mind-bending concept is called retrocausality, and it suggests that the future might not be so fixed after all. One of the most famous experiments in quantum mechanics is the double-slit experiment. It's been puzzling physicists for decades and provides a glimpse into the strange behavior of particles at the quantum level. Imagine shining a beam of light at a barrier with two slits. Behind the barrier, there's a screen. When you shine the light through the slits, you'd expect to see two bright lines on the screen, right? That's what happens with normal waves. But with light, something strange occurs. Instead of two lines, you see an interference pattern, a series of bright and dark bands. This pattern suggests that light, which we usually think of as a wave, is also behaving like a particle. Even stranger, when you send single particles of light one at a time, they still create the interference pattern, as if they're interfering with themselves. This is where things get really interesting. The double-slit experiment, along with other quantum phenomena, has led some physicists to propose a new way of looking at time in quantum mechanics, called the two-time formalism. This approach suggests that particles are influenced not just by their past, but also by their future. Think of it like this. Imagine a particle is like a tiny traveler navigating a maze. In the traditional view, the particle's path is determined by its past movements. But in the two-time formalism, the particle is also receiving signals from the future, guiding it towards its destination. This means that the particle's journey is shaped by both its past and future, making it difficult to say which one is truly dictating its behavior. This is retrocausality in action, the idea that the future can influence the past. Section 4. A cosmic GPS. To understand retrocausality better, let's consider a more familiar example. GPS navigation. When you use your phone to navigate, your device receives signals from satellites orbiting Earth. These signals help determine your location and guide you to your destination. In a way, these GPS signals are like messages from the future, telling your phone where it needs to go. Your phone's current position is being influenced by information from its future location, much like a particle's journey might be influenced by events that haven't happened yet. Another analogy is a school play. Imagine you're an actor on stage, delivering your lines. Your performance is shaped not only by the lines you've already spoken, but also by the knowledge of the play's ending. You're acting in the present while being influenced by the future script. Section 5. Rewriting reality. The implications of retrocausality are profound. If the future can influence the present, does it mean that free will is an illusion? Are our choices predetermined by events that haven't happened yet? These are questions that philosophers and physicists are still grappling with. Some argue that retrocausality doesn't necessarily negate free will, but rather suggests a more complex and interconnected relationship between the past, present, and future. In this view, our choices might be shaped by a web of influences, some from the past and some from the future, but we still have the ability to make decisions within that framework. Others believe that retrocausality challenges the very foundation of our understanding of reality. If the future can influence the present, then the arrow of time might not be as straightforward as we think. Perhaps time is not a linear progression, but a more fluid and dynamic dimension. Section 6. The future's grip. The idea of particles being influenced by the future might seem like science fiction, but it's a serious area of exploration in modern physics. While still theoretical, retrocausality has the potential to revolutionize our understanding of time, causality, and the nature of reality itself. It challenges us to rethink our place in the cosmos and consider the possibility that the future might not be a blank slate, but a force that shapes the present in ways we're only beginning to comprehend. Perhaps the universe is engaged in a cosmic dance, with the past, present, and future intertwined in a delicate and mysterious embrace.